Thank you, folks. Thank you, virtual learners, for being with us. We'll continue on this thing. That this is another thing where the software also tell you what activities where you can do it, what is called ocean waters, what is called coastal waters. So these are some of the coastal water thing which we are going to look at it, and certain places you are not allowed to do ballasting, so they will stop you from deballasting there. If ballasting, yes, you can do anywhere, but for deballasting you can do in certain areas. So high risk areas are identified in this software. Those high risk areas are all, you can see, around Europe. These are the high risk areas. Then Mediterranean is also in high risk areas. South Africa, South Coast, near Japan, Malaysia, some part of China, they are also high risk areas. So in the high risk areas, we are very careful. Then of course, highest risk areas. Then those yellow dots are still high risk areas. The amber dots are medium risk areas. I don't know if the camera is in right position for them to see. Then we have got the green areas, which are low risk areas, and dark green is the lowest risk areas. So that is how we are managing it. So now, are you happy so far? The next thing which we are going to talk about is record keeping of ballast water management plans. The date, what dates you are doing what activities in there.
A solution for that, just
Yeah, okay, and you will okay. So it is all yours. Once that is done, then I will come. So the geographical location of the ship, not in terms of the areas only, but also for the latitude and longitude of certain areas. Ship tanks and cargo holds to be used. Why we are saying cargo holds? Cargo holds that in certain ships for and heavy weather ballast, we are allowed to load in our cargo holds. But mostly on a gas carrier, we never take any ballast in our cargo holds. So that is not applicable to us. But of course, our ballast tanks are applicable to us. Ballast water temperature, because a lot of species survive on certain temperature and they die in certain temperature, means warm water species. If we bring and discharge it in the North Sea water, a very cold water temperature, they might die because of the thermal shock or other reasons. Salinity of ballast water means, are we loading it as a fresh water? Are we loading it as a brackish water? Are we loading it as something different? Amount of ballast water loaded and discharged. So far, what you have loaded, what you have discharged, how many times, how much you are retaining, what is the condition of it, and all these things. These are one of the requirements which are the basic requirements. Then there are certain other requirements which is with the D2, where you are putting the information about your plant, how you are killing those species or getting rid of those things. This is what it is generated. Either you generate it on a manual level in the system, or you just put an information in the computer, and the computer database will generate this thing. You can see the IMO number of the ship, the identity of the ship. You can see the date of arrival. For example, in this case, it is Baltimore, USA. Total ballast on board volume should always be greater than equal to the sum of discharge volume listed in section 5. Okay? So what you are discharging, number of ballast tank used, underwent exchange or treatment, whatever is the applicable. All tank listed must include the discharge information. This volume here is the sum of two pair tank volumes. So that's why we are saying 10 port or 10 starboards or things like that. So basically, this is just the information. Anybody who is seeing it from a remote part, they can see your compliance from the ballast water management code or legislation. And of course, this is a reporting form. This is a generic form. It could be in an electronic format. It could be in a manual format. And of course, it needs to be signed. In this case, it is a manual one, which was signed by the chief officer of that vessel. So now, we will talk with regard to our simulator here, or our vessels here. We will of course manage, when we will do the ballasting, you will manage it here. Regular sounding or alleging for quantities measurement. You will do also the stress calculation for hogging and fragging. We will give you a lodicator for that vessel. So you will separately work on a lodicator. Then we will also control the flow rate management. Initial and final means initially you will always start with a slow rate. Then of course you increase the rate to the maximum. Then of course again towards the end, when you come to the stripping level, you trim it down, or when you are coming to the topping off level, you slow it down. We try to avoid under or over pressurization of tanks. This is our one of the objectives. We do not want to put liquid so fast that we cannot take the air out from or the metal. So we do not want to pressurize it when we are ballasting. Once we are discharging it, we do not want to discharge it under under the vacuum condition. And pumps and pipelines are to be maintained under advised operational parameters. Duty officer and engineer should keep an eye on the suction and discharge pressure of the ballast pump for any deviation. So this is what you will be doing tomorrow morning on the simulator. Chief officer, chief engineer must be part of contingency procedure which has to be deployed due to a failure of a ballast pump. And he must have a standby arrangement ready for it. Chief engineer should provide an estimated figure of ballast pump discharge capacity based on machine trial records, maintenance record conditions. So this is what you are going to experience tomorrow when we'll give you the ballast management exercise or ballast management objective, and you will do the ballasting of the vessel, and you will also do the deballasting of the vessel on the simulator. Let's press on. As air pipes are not normally designed for continuous ballast water overflow. Why we are saying it? You are naval architects, you know what I mean. Is many times what they do is they keep on running the pump and they let it overpressurize. So for example, your line capacity is 1000 cubics an hour, and your pump capacity is maybe more than that. Your Overflow vent may not have that kind of to overflow. So it will give a pressurization on your tanks, because tanks has already got an head pressure. In addition to that, they will also give a back pressure on the ballast pump, which is not good for the health of the vessel and the ballast pump. Can you have a look? Is there somebody online or somebody has sent any message? Is it okay?
Yeah.
Okay. So, so what we are trying to do is duty engineer or officer of watch for any increase of discharge pressure of a pump in variation of amperage and prime mover motor. So if the ampere or loads are rising on it. So tomorrow in this simulation, I am going to create certain scenarios for you. I will be on the control panel where you will be, dealing with those things. Chief officer and duty officer, they should appropriate precaution in freezing weather. This is one of the things. Sometimes in freezing weather, we need to continuously ballast, or sometimes we add salt to the tanks, or we take certain measures, to avoid the freezing inside the tank. Chief officer or duty officer should calculate in advance probable change of stability during the ballast water exchange, which you will be doing tomorrow. Senior management should advise and train the deck crew and operational level officer about the methods to ensure the sounding pipes and air pipes are in good order and non-redundant good cruise necks air pipes in working order. The chief engineer must advise the chief officer about the variable timing of ballast water. Okay, so these were certain things. The duty engineer down there in the engine room should also advise about the certain things they are, what is happening over there. So that is one of the given things, is that we may be able to do mid-ocean ballast water exchange, which you will be doing tomorrow. Mid-ocean ballast water exchange in the normally whenever we load the ballast, we are normally in the port, very low shallow waters, and this mud normally comes into the tanks, which poses a lot of problem into the tank. So what very often people do, they start pressurizing the tank, which is not a good idea. But if you can see from the sounding pipe, it is also jetting off. It is jetting off here, but it is giving load to the tank walls and also on the other pumps and etc. So this we will practice in the simulator ballast exchange. We take ballast. In the middle, we will try to, exchange the ballast. Exchanging ballast is discharging certain tanks and loading certain tanks in an exchange. But do you think it is a good idea to do it like that? What will happen if you discharge all 3 tanks here and load all 3 tanks forward? The ship is going to take a nosedive. So we may do an alternative tank loading, an alternative tank discharging. So when the reaches in the next port, of course, the vessel will, can easily discharge. Why we are happy to an extent with the ocean water? Because the ocean water always have a high salinity, and it has comparatively less in it. And those species which are in ocean or the middle of ocean, because of ocean currents, the Coriolis force and the world ocean currents, they are always revolving. They are always rotating around. So we are not really worried about them. So we can manage with them. And this is another ballast water management thing where we have got a filtration unit. We are taking, loading the ballast and using the filtration unit. So far we have seen you an UV treatment, ultraviolet treatment. We have shown you the removing of oxygen or using of inert gas. But this is another system which we have got a filtration unit. In the filtration unit, we are holding the plankton, we are holding the mud and sand, and we are holding the bacteria. And once we are discharging, and of course there is certain chemical feed unit which is, neutralizing those invasive species. So this is how we are controlling the ballast. But while we are controlling the ballast, the ship goes through hell. What do we mean by that is that ship will experience lot of stresses, certain shearing forces, certain bending moment. This is what you will experience tomorrow on the simulator, that how we can mitigate it, how we can control it, how we can do better planning of it. Okay, this is what we will do tomorrow. So this is a typical drawing of a filtering system which you can have a look. So there are two. One is on the top, one is at the bottom. So see, compare and contrast.
Hi, this is Mohammed Shafiq. Can you confirm my appointment is at 5:30 today with Dr. Vipin? Yeah, 5:30.
So this is the ballast tank, this is the system. So this is again coming under the D2 arrangement of the vessel, where we have got a neutralization unit, we have got a filtering unit, and electrolyzer, where we are, neutralizing these species, and we are doing this process in both ways. When we are doing it, when we are doing the ballastic, we are trying to filter out all these invasive species, and when we are going the other way around, is we are removing the chlorine from this, because here we are dosing hydrofluoride, and here we are doing neutralizing that thing, so we are not damaging the environment where we are deballasting our tank. So this is the ballast system. Sea chest, ballast water pump taking the water, smart pipe unit, electrolyzer unit, and then the ballast tank. When we are deballasting, we are taking it from there, deballasted water, taking it to the pump will push it, neutralization unit, and we are discharging back to the. Very simple process. Lot of different manufacturers have created different products. Everyone has got certain pros and cons, and they are, but they all serve the purpose. So they will get the classification societies approvals and administration approvals on their performance. So what they are doing, we call this thing as ballast water treatment technologies. So solid liquid separation, filtration, hydrocyclone, coagulation, and of course chemical disinfection and dechlorination, ozone chlorination, different thing, and of course physical disinfection is the ultraviolet radiation, deoxidation, heat, magnetic treatment, which is a physical and mechanical and chemical both. Then we have got micro agitation, which we are trying to create cavitation and kill those microorganisms in the cavitation. You know the cavitation bubble, which I will explain you later. And of course, we also do ultrasounding, where we try to kill this, and of course, advanced oxidation using TiO2, OH, Fe6, and other gases to oxidize it. Anything which is too less oxygen, this will not survive, and too much oxygen, they will not survive. So, folks, this is ballast water sterilization unit. Can you try to make sense of the lines? Because this is what you will be doing on simulator tomorrow. So if you are happy here, now I'll ask you a question in a couple of minutes. You see, and you are going to tell me what is happening here. Think about it, think on the lines. We are more interested in the lines. So what it is doing, can you tell me?
Look, for us, the main line is not passing through the filter unit. It just bypass the filter unit and circulate.
So taking the ballast water in through the pump, passing to the ultraviolet system, and treated water is drained. So if you have loaded already the ballast water, which you have already filtered, now filtration does not mean we have killed every single microorganism. They can thrive during their stay in our ballast tank. Now, if the ballast tanks are not inerted or things like that. So this is what we are doing while we are discharging. We call it UV treatment or ultraviolet treatment. We often use it in our home domestic filters, which kills, they claim it kills 99% of the bacteria. So even the bacteria is killed with the thing. So this is one system which you have already seen it in there, which is the inert gas in the ballast. Inert gas in the ballast system means we have got just an IG system running, and you can see in the inert gas main line that is on tankers, especially in gas carrier, we have no problem of running an inert gas plant. So pressure vacuum breaker is over there in that corner. Gas lift diffuser, so we are using the diffuser to diffuse gas in it. Tank monitoring system, which is the gauges in the green, and gas lift diffusion pipes at the certain level, you will have the diffusion pipe. So this is how we are trying to use the inert gas to reduce the oxygen content within the tank or within the ballast to kill the invasive species. So folks, that was it about the ballast water management. So now I will show you a very short video for tomorrow. Now, which is taking, you have missed that one part this morning, which you are going to be here all day, all week from tomorrow onwards. Okay, that is fine. Others, can you just talk to the other fellows who are not here? They can join tomorrow because university is starting tomorrow. So let me show you that. Any questions, folks? Can you close the mic over there? I don't know why it has picked me up from the system.
To close it?
The mic only because they will get fed up. Is there any
A question from Mr. Vasilios Christakis about if there is any assessment or test for this course.
No, there is a short MCQs, but since this course is delivered on the system here, on the simulator, we are teaching you the theory, we are teaching you the use of simulator, and then you practically do the stuff over there. So once you are doing this work on the simulator, this is what we are assessing. The simulator will assess you. We have got a system there which will tell us what mistakes you have done, and also we can see what things you have done. But I will create some to do a kind of summative assessment. We have created a very short MCQs, multiple choice question, which you will get on Friday. At the end of this.
The students from distance learning will be provided by these questionnaires.
Technically, this module was for present students, so we cannot assess them there. So what I will do is I will pass it to you or Stuart, and you can put it on for
upload
them.
Okay.
Upload it, and they will.
So there will be a questionnaire.
There will be a questionnaire at the end, or from the virtual learner when we will have time, when you are working with the simulator, I will interact with these virtual learners.
That's very good.
On the system. So I will engage them also in the learning process.
Okay.
What I will try to do is I will dedicate it to your computer, so where they will see the work of, maybe I'll attach with the computer of our colleague here, and he will, whatever he's doing, they can observe it and they can also interact through that. That is the best way we can engage the learner, which are virtual learners outside this town. Any other question?
Have you covered with the answer, Mr. Christakis?
You can ask any question.
Okay.
Has he got any other questions? Has he asked any other question?
No. Can we have links for today's sessions sent to us via email about your presentations?
So I don't have anything. Have you recorded anything?
Yeah, everything has been recorded. All the sessions. So there will be uploaded in a Dropbox file and will be shared to the registered students either to those that are here, or both those that are here and those that are from distance learning. So you will be served with these links. Just make sure everyone that has done the register properly, sending an email to the email address that you provided through the advertisement PDF.
I think we'll call it a day now for our virtual learners.
Yeah.
Because we need to work on the simulators for preparing it for tomorrow.
Okay, so
We'll call the James to sort it out. So we'll thank our virtual learners for their presence on the system. And tomorrow's session will be a little longer because we will be working on. Okay,
what time we will start?
we'll start at 9 o'clock UK time. And tomorrow we'll continue till 5 o'clock tomorrow. Okay. So, folks, do you have any questions so far?
I think that they are covered from the last questions about how they can find the presentations and about the assessment. So I think that we are okay, and we can continue tomorrow.
Okay, so just say thank you to everyone, and we'll continue on tomorrow.
Okay.